that this condition, it means at the initial level, should be present in the power. A, why we are talking about this condition? This condition is at the beginning of this interval, that is at at the point A, and second condition is at the end of the interval, at means at B. So that's why it is given that even A2 both can't be 0 and B1 B2 both can't be 0. So a differential equation like this one together with the boundary condition, these are called Sturm-Liouville's boundary value problem. Okay. So next question, when we are going to use these, then we can find the solution of this differential equation. Yes, again I want to know something from your side. Who tell me? Ritik, Ritik, no idea. Ravikant, Ravikant Yadav, yes Ravikant, Ritesh Raj, no one is going to speak. Mithilesh Kumar Yadav, Neha,
Yes, sir.
Neha, good. So just a minute. My screen is visible.
Yes, sir.
This differential equation is a homogeneous differential equation or non-homogeneous differential equation? Homogeneous or non-homogeneous?
Sir, it should be non-homogeneous because not all of them are in the same degree.
Same degree.
Yes, sir. Like P of x is d by dx and Q of x is d by dy.
You are talking about the linearity or homogeneity? I am talking about the homogeneity. Whether the differential equation is homogeneous or not.
Acha, yes, sir. Homogeneous. Yes, sir. Sorry.
Is it homogeneous or not?
Yes, sir.
Okay, homogeneous. So every homogeneous differential equation has trivial solution.
Sorry, sir.
Every differential equation has trivial solution or not?
Yes, sir.
Yes. So this is a differential equation, homogeneous. So we all know that every homogeneous differential equation has a trivial solution. Trivial solution means y equal to 0 will always be the solution of this differential equation. So in that case, nothing to do. It's simply if a differential equation is homogeneous, then whatever the kind of differential equation, y equal to 0 will be always a solution. So we are not interested in that solution. So we are interested in non-trivial solution of this differential equation. So to find the non-trivial solution of this differential equation, the value of lambda should be chosen accordingly. So the value of lambda for which this differential equation will have non-trivial solution is called eigenvalues, and the corresponding solution will be the eigenfunction. So our aim is to find the value of lambda, which will give us the non-trivial solution of this differential equation. Okay, so just a minute, wait a minute. Yes, please. So our goal is to find the value of lambda, which will give us non-trivial solution. So the whole story behind this Sturm Lewis differential equation is to get the value of lambda. So already I mentioned that, as we know that Sturm Lewis differential equation 5 is homogeneous differential equation, has always a trivial solution, but we are interested in non-trivial solution of differential equation 5. So the value of lambda for which non-trivial solution differential equation exists are called eigenvalues of the Sturm Lewis boundary value problem, and corresponding solution Ys is called eigenfunction. And the set of eigenvalues of the Sturm Lewis boundary value problem is called the spectrum of the problem. So it is the whole theory behind the Sturm Lewis boundary value problem. It means our goal is just to find the eigenvalues and then corresponding eigenfunction. Now, so based on this one, I don't remember whether we have been started the questions. Question is find the eigenvalues and eigenfunction of the boundary value problem. Y double dash plus lambda y equal to 0. And you may see here boundary condition are y0 equal to 0 and yl equal to 0. So first, when lambda equal to 0, there are three conditions. One, lambda may be 0 or greater than 0 or less than 0. So we will discuss all three cases. We assume that lambda equal to 0. When lambda equal to 0, then y dash plus lambda y equal to 0 will becomes y double dash equal to 0. And in this case, y will be a plus bx. Simply we may integrate it. So first y dash equal to some constant b, and then again we are going to integrate, then a plus bx. Now when we will use these two boundary conditions over the solution, so at x equal to 0, y is 0, it means a will come 0. And at x equal to l, y is 0, so it is going to be 0, x is l, and a is already 0, so we will come 0. It means a0, b0, which will give us y equal to 0, which is a trivial solution. So when lambda equal to 0, we are getting trivial solution. Okay? Yes, Nidhi. Nidhi? Again, she's not there. Nidhi, are you not there? Faraz Samin? Faraz Samin? Rajat Bansal? Shivam Pandey? Vijay Kumar?
Yes, sir.
Chalo, Vijay comes from, who is speaking? Vijay or Sachin?
Sir Sachin.
Sachin. Good. So Sachin, if lambda equal to 0, then we are getting y equal to 0. The trivial solution. So what you can say, whether this lambda is the eigenvalue?
Mm, no, sir.
No. That lambda will be the eigenvalues which will give us non-trivial solution. So now we are taking another case, lambda less than 0. Then lambda equal to minus k square. Thus in this case, y double dash plus lambda y equal to 0 will come like y double dash, and lambda is minus k square, so k square y. So the solution of this differential equation will come a e power k x plus b e power minus k x. So in this case, again we are going to use the boundary condition. X equal to 0, y is 0, it means a plus b equal to 0. And second boundary condition, x is 0 then y is 0, so this y is 0, a e power kl plus b e power minus kl equal to 0. So when we will solve these two different system of algebraic equation, then we will get the value of a and b both as 0. You may see b is equal to minus a. We may use here b equal to minus a. A can be taken common. Then e to the power kl minus e power minus kl. So since E for KL minus E for minus KL can't be 0, hence E is 0. So if A is 0, then B is also 0. So again, for this value of lambda, we are getting trivial solution. So again, this lambda will not give us eigenvalues. Now, third case, when lambda is greater than 0, then lambda equal to k square. So in this case, we are getting y equal to a cos kx plus b sin kx as a solution. Now, again, we are going to find the values of arbitrary constant with the help of boundary condition. So, boundary condition means x equal to 0 and x equal to L. So, at x equal to 0, y is coming 0. So, x equal to 0, a cos 0 and sin 0 is 0. So, it means a will come 0. Now, if a is 0, then second y equal to b sin kx, we are going to use the second condition, it means 0 is equal to b sin ki. So, b sin ki equal to 0. So, either b is 0 or this sin ki is 0. There is a possibility of sin ki is 0. If b is 0, then again we get the trivial solution. We are not interested in trivial solution. That's why sin kl is equal to 0. So sin kl is equal to 0 will give us kl equal to n pi. This k equal to n pi by n, where n varies from 1 to 3 and so on. So in this way, lambda will come. Lambda is k square and k is n pi by l. So n square pi square by l. So this value of lambda, which is giving non-trivial solution, is called eigenvalues, and corresponding function, that is solution. The solution y equal to a is 0 plus b sin the value of b sin kx. So kx means x is n pi by l. So n pi x by l, it will be the eigenvalues and function of the given boundary value problem. Similarly, another question, consider the eigenfunction for the periodic stem Lewis boundary value problem y double dash plus lambda y x equal to 0 and y minus pi equal to y pi and y dash minus pi equal to y pi. So again, we have two boundary conditions and one differential equations. So we will go for the yes. So in this case, we can get the solution with the same procedure. We will get the solution. Now, Sturm-Liouville's theorem. Let us consider a Sturm-Liouville's differential equation on some interval AB as d by dx Rx divided by dx plus qx plus lambda px y equal to 0, where px, qx, rx and r dash x all are real value continuous function defined on closed interval AB, and px is greater than 0 for all x belongs on the interval A. So this differential equation. Now, if ym and yn are the eigenfunction correspond to the distinct eigenvalues lambda m and lambda n respectively. Please be careful. Already you have seen that the value of lambda for which this differential equation have non-trivial solution is called eigenvalue, and that solution is to eigenfunction. Earlier you have seen here also, by changing the value of n, the value of lambda will change, and coming to that lambda, the solution will change. So question is, theorem is here, if ymx and ynx are the eigenfunction corresponding to the distinct eigenvalues lambda m and lambda n respectively, then ymx and ynx are orthogonal to each other on the interval, closed interval a. With respect to the weight function px, orthogonality you know already. Orthogonal with respect to the weight function px means integration from a to b pmx into ymx into ynx dx equal to 0, where m not equal to n. If m and n are the two distinct eigenfunction for the two distinct eigenvalues, it means m is not equal to n is assumed here. So it is very good result. If we have this differential equation and it has two different eigenfunctions corresponding to distinct eigenvalues, then both functions will be orthogonal corresponding to the weight function px. What is px? Px is nothing, it is the coefficient of lambda. So we need to prove this theorem. I'm not going to prove this theorem. You may try to prove this theorem. This is the result which we need to discuss here. So, as per the syllabus, we have been covered first unit as well as second unit. Orthogonality, orthogonal polynomial and functions have been already discussed. Now, anyone wants to ask any question, please? Shivangi,
Yes, sir.
any doubt? Then you, anyone may ask a question, please. Just I'm sharing the screen. You may see the screen. This portion have been completed. You may see unit 1. My screen is visible.
Yes, sir, it's visible.
So you may check. Orthogonality already have been discussed of the legendary differential equation as well as Bessel differential equation. Okay. Now next topic is function of complex variables.
Excuse me, sir.
Yes, please.
Sir, can you please tell about mid-semester examinations? Will they take place or not?
No, I will take the quizzes. Some already I have given the questions during the lecture. Do you remember?
Yes, sir.
So all are the parts of mid semester examination.
Okay, sir. So there is no separate examination.
No, sir, not individual examination, whatever. Because as per the online system, I uh, I I need to take the surprise test, quiz, other things. So which I've already started.
Okay, sir. Thank you, sir.
All those constitute the mid semester. Okay. So based on that one, I will give the marks of the mid semester. I will show the marks already. I will show the marks of all. Okay. So as I remember, how many tests was conducted? Two or three.
So for ECB, I think two.
And for whole EC not given, na?
Oh yes, sir. Some you have given an EC3 tutorial, and for ECB as a whole, you have given two quizzes,
Two
two
quizzes. Okay.
assignments.
Two assignment, na? So that was yes. Anyway, I will take that one. Okay. So next topic. What I'm planning to. Just a minute. So you all can prove this theorems. The stability is boundary value problem. No. Now we have done. I think we can prove this theorem. So I will start the next topic from the next class because these two have been completed. So we need to discuss next function of complex value. As already told that unit 3 and unit 4 are the based on the complex value. Okay. So from the next class, I will discuss the function of complex variable and other things. And it's my advice to most of the students, Sivangi,
Yes, sir.
you may also given the instance to others that from the next class, they are going to start the new topic, function of complex variable. So it's advice from my side to present in the class so that from the beginning, so that they can understand this topic easily.
Yes, sir. I'll
Now,
tell them.
yeah, just now the proof of the proof of the stability boundary value here. So now write down let lambda m and lambda n are two distinct eigenvalues and ym and yn are and ym x and yn x Okay, so let lambda m and lambda n are two distinct eigenvalues, and lambda ym and yn are their corresponding eigenfunction. Thus, as per the thus, what is your Sturm-Liouville differential equation? R d by dx of r x divided by dx plus this one. Sturm-Liouville's differential equation is this one, corresponding to the, so just see here, I'm not writing here. So if lambda m and lambda n are two distinct eigenvalues and ym and y are their corresponding eigenfunction, so here I think becomes ym, we may say ym, and here we may say lambda m. Thus we have this equation. It is for lambda m, and second equation we are going to replace m by n. So we will get it easily. Now our aim is to find the integration of the product of px, lambda, ymx and ynx. Here in place of here ym, so ym will also be here, and here yn will be there. Yn. Okay. Now you know what we should do. We need to do. Now we need yn here. So equation 1 multiplied by ynx then minus equation 2 multiplied by 2 by ymx. This implies what will happen? We may write all these. First I'm writing here, and we need to multiply this by ynx. I'm writing here as well as here, then minus this whole terms this one, and we are going to multiply this one with ymx, and then equal to 0. Now please simplify this one. Yes, please. So we may think about this one. What we can do from this term and from this term. I think qx, yn will be cancelled out. Yes, so from the so this these two terms, please check, can we write or not? I'm writing here d by dx of Rx y d by dx of ym, and here ym d by dx of Rx d by dx of ym. So it can be written in single terms. Single terms. How it can be written? So d by dx of d by dx of ym and within bracket I'm writing this one as Rx then ym dash, ym dash, then minus the same way here yn and here uh, yn then yn here, not yn and here if yn then ym dash. We check and confirm it plus. Then you will differentiate it. Then you will get these two terms from here to here. We may assume this equation as number 3. Now nothing to do, just integrate this equation. So integrating equation 3, and I hope you all know we can integrate it. Why? Because of Rx, Px and Y. All are continuous. It is given already that all are continuous on a closed interval AB. So integrating equation AB with respect to integrating equation 3 with respect to x, integrate equation this with respect to x from A to B, from A to B, you will get the results. So just what you will do, you will integrate this equation. You know here derivative, it means its integration will come like simply this from A to B. Then we will take the limit at x tends to B, then minus as x tends to B. And here the integration lambda m minus lambda n px ym from A to B. And then you will get the results. So we will complete this proof of this theorem, and I will just create a place. So there you may send the proof of this one, complete proof. Okay, wait a minute, I will take attendance, then I will leave the class. Yes, now you may leave the class.
Thank you, sir.
Welcome.
Thank you, sir. Oh, thank you, sir.
Thank you, sir.
Welcome.